The M2 Bradley has served as the iron workhorse of the United States mechanized cavalry for over 4 decades, proving its worth from the deserts of the Middle East to the muddy trenches of Eastern Europe. However, this legendary platform has finally hit its absolute physical and technological limits. Its successor, the XM30 Mechanized Infantry Combat Vehicle, formerly known as the Optionally Manned Fighting Vehicle Program, is not merely a localized upgrade, but a quantum leap in ground combat architecture. Built upon a modular open systems architecture, the XM30 is designed with a digital backbone that allows for seamless integration of new sensors, weapons, and software without requiring a complete vehicle overhaul. While the traditional Bradley was designed as a heavily armored battle taxi operating with 3 main crew members and carrying a 6-man infantry or scout patrol team in the back, the XM30 shifts this paradigm entirely. It is optimized to be operated by a typical minimalist crew of just 2 personnel, a driver and a commander, while advanced artificial intelligence takes over the complex gunner functions. The rear compartment remains dedicated to transporting a 6-man fully equipped infantry squad, transforming the vehicle into a mobile command hub integrated with smart rifles, augmented reality helmets, and pocket drones. Firepower has also seen a massive escalation, replacing the Bradley's standard 25mm Bushmaster cannon with a devastating Northrop Grumman XM913 50mm autocannon capable of firing programmable airburst rounds. Furthermore, the XM30 introduces hybrid electric propulsion, enabling a silent watch and silent drive capability that drastically reduces both acoustic and thermal signatures while moving stealthily through contested environments. The Pentagon urgency to replace the Bradley stems from a collision of exhausted engineering and the brutal realities of modern asymmetric warfare. Over decades of service, the military continuously overloaded the Bradley chassis with explosive reactive armor, communication suites, and electronic jammers, pushing its weight well past 35 tons. This relentless addition maxed out the vehicle's suspension and drained its electrical generation capacity, leaving no room to power modern active protection systems or internal drone launchers. The live-fire audit of this reality occurred during the war in Ukraine, where Washington supplied hundreds of M2A2 Bradleys to the Ukrainian military. On one hand, the Bradley proved incredibly resilient and lethal, famously demonstrated, according to verified combat footage, when 2 Ukrainian Bradleys successfully engaged and disabled a highly advanced Russian T-90M main battle tank by continuously peppering its optics and tracks with 25mm fire. The vehicle-spaced armor also saved countless crew lives from artillery strikes. However, the battlefield also exposed a terrifying new paradigm, where traditional frontal armor is rendered increasingly vulnerable to cheap, top-attack threats. Swarms of inexpensive kamikaze drones, alongside advanced smart mines, have become dominant threats, often bypassing the Bradley heavy frontal plating by striking the vulnerable roof of the turret. This exact vulnerability is why the XM30 is mandated from its inception to feature enhanced top-attack protection through modular composite armor and layered active protection systems, or APS, alongside integrated counter-UAS sensors and electronic warfare components to defeat drone swarms before they can strike. Following previous failed attempts to replace the Bradley, the United States Army has now locked into an aggressive and unforgiving timeline to field the XM30. The competition centers on a massive contract valued at approximately $45 billion to replace the entire Bradley fleet. In mid-2023, the military officially narrowed the field down to 2 defense industry titans, General Dynamics Land Systems and American Rheinmetall Vehicles. Both consortiums are currently operating under a compressed schedule to finalize their engineering and manufacturing development phases. By the latter half of 2026, both competitors are required to deliver fully functional physical prototypes to the Army. These vehicles will be subjected to brutal field testing, including extreme weather endurance, electronic warfare jamming scenarios, and intense live-fire exercises. Following these rigorous evaluations and soldier feedback, the Pentagon plans to select a single overall winner in the fiscal year of 2027, granting them the right to begin low-rate initial production. If the developmental milestones remain on track, the first operational XM30 units will officially equip active combat brigades by 2029, marking the definitive beginning of the end for the M2 Bradley tenure on the front lines. The battle for the XM30 contract represents a clash between two highly distinct engineering philosophies. General Dynamics Land Systems proposes a purpose-built design leveraging technologies from its Griffin 3 demonstrator, emphasizing a battle-proven lineage mixed with modern enhancements. Their design features a heavily protected hull capsule for the two-person crew, an unmanned 50mm turret, and a strong focus on evolutionary reliability that leverages an established American manufacturing footprint. Conversely, American Rheinmetall Vehicles, in partnership with technology firms like Anduril Industries, offers a heavily customized variant of the Lynx KF-41. The Lynx proposal leans aggressively into modular innovation and artificial intelligence, offering a plug-and-play architecture that maximizes infantry flexibility. This design heavily emphasizes advanced AI for drone detection and target prioritization, pushing the boundaries of software-driven combat. Both platforms exceed the legacy Bradley in every metric of lethality, survivability, and power generation. But the Army final choice will ultimately come down to a preference between GDLS proven, Americanized evolutionary path and Rheinmetall bold, software-centric European innovation. The XM30 Mechanized Infantry Combat Vehicle is not simply the endpoint of infantry transport. It is the bridge to an entirely new era of mechanized warfare dominated by artificial intelligence and robotics. Designed fundamentally as an optionally manned platform, the doctrine for the 2030s envisions a battlefield where human risk is drastically minimized. In the near future, a single crewed XM30 could act as a command node, orchestrating a Wolfpack of 3 or more completely unmanned XM30 operating as scouts, decoys, or remote shooters. Through deep integration with loitering munitions and ground-based robotic combat vehicles, the infantry squad becomes a distributed network of sensors and shooters rather than a single vulnerable target. Ultimately, the transition from the Bradley to the XM30 is a definitive statement by the Pentagon. The future of ground combat will no longer be decided by which military possesses the thickest steel armor, but by which force can process data the fastest, move the quietest, and seamlessly integrate human soldiers with autonomous machines in the kill zone.